Hello, I'm Karen Boyd, and I'm here to discuss my paper, Datasheets for Datasets, Help Machine Learning Engineers Notice and Understand Ethical Issues in Training Data. First, a quick reminder of some of the problems that have arisen from training data being collected and reflecting the biases of the people who collected them or the problems in the social world where the data came from. To prevent these kinds of problems in machine learning-driven technologies before they're released and used, someone in the development pipeline needs to notice a potential problem in training data, understand what they could do to address it, and have the power to make a change moving forward. This study looks at these first moments of training data curation using a framework from the study of professional ethics called ethical sensitivity. Ethical sensitivity describes a person going about the technical aspects of their job task when they notice a cue, something that signals to them that there may be a potential ethical issue here. Imagine that you're an accountant and you encounter a whole bunch of weird transactions or a really large transaction. It might cause you to say, that's weird. This moment of noticing is called recognition. Then you may go on to seek information about the transactions, maybe look up the relevant laws, ask someone, hey, do you know what happened here? And you may also reflect on how that problem relates to your own responsibilities, what your sort of professional ethics are telling you, and think about your options and resources, stuff like that. This phase is called particularization. And then you may go on to decide what to do next. You might say, I need to talk to the client about this. You may say, I've got to report this, or you may say, this isn't an ethical problem or isn't my problem. Although we might think this is a linear process, literature suggests that there are sort of developmental judgments that are made along the way, and then you realize, you know what, I need more understanding, and so you go back. There's a bit of a feedback loop between particularization and judgment. So ethical sensitivity has been studied in a wide variety of professions that have ethically consequential work and no concrete heuristics to tell whether a situation is ethically consequential. You can see over here on the right a series of professions that have been studied in the ethical sensitivity literature. But technologists and machine learning engineers are not on that list. Machine learning engineers do have ethically consequential work. It is difficult to tell whether a situation is ethically consequential. And they may also have technical expertise that is required to recognize, particularize, or judge. They also have very limited occupational closure, and that means that there's no consistent curriculum that ML engineers take where we could sort of disseminate best practices, nor is there any licensure body enforcing those. So I wanted to observe and describe how machine learning engineers recognize, particularize, and judge when they're looking at unfamiliar training data. And I also wanted to test an intervention that claims to help people notice and understand ethical issues. So the intervention that I selected is one of a type of intervention that I'll call context documents. These are documentation that accompany models or training data, and among other things, help people notice ethical issues. All of these have additional purposes as well. But that's what brings them together. So there's sort of three ways you can classify these. First, they could be looking at the model or the training data. I was looking at training data for reasons I'll talk more about in a second. I also wanted something that was general purpose. Although I think technique and domain specific interventions are super valuable, for this sort of exploratory study, I wanted something where we could recruit not just people doing, for example, NLP, but any machine learning engineer. You can also classify them by their presentation. I was looking for something that had lay language. So it was not using sort of really technical language. And you can see that Gabru et al. 2018 is the only one that fits, that is for training data, is written in lay language, and is general purpose. So this intervention is called Datasheets. The fact that it's for training data, it's technique agnostic and domain agnostic, and is written in lay language, means that we can, first they intervene early in training data curation, also when they update models and things may have changed. It's also teachable across specializations in like an introduction class to ML engineers that may go on to do all kinds of techniques in all kinds of industries. And it's also legible to managers, users, citizens, regulators, because it's in lay language. Study with a debrief interview afterwards. I gave them, I used a think-aloud comparison study with a debrief interview after. I used a think-aloud comparison study with a debrief interview afterwards. I recruited 23 participants and gave each of them a facial recognition data set with planted ethical problems, a problem statement describing a jewelry store that wanted to catch thieves, and 11 of those 23 I gave a data sheet. To observe ethical sensitivity, I looked for a few things. For recognition, I was looking for mentions of ethical issues. I wrote down what they said, when they said it, and what they had on their screen. I also asked at the end in the debrief interview, at the very end of the interview, did you notice any ethical issues? I want to ask this because I wanted to capture situations in which people noticed an ethical issue or could imagine an ethical issue, but didn't bring it up while they were working. So for particularization, I looked for instances where people were seeking information or reflecting on some aspect of the situation. For example, stakeholders, potential consequences, their responsibility, options, resources, and the relationship between the ethical problem and their task. I recorded the comments, the information sought, the information source, and the duration. I didn't think that very many people were going to make a final judgment about what to do here in the first 30 minutes of looking at this data, but I did record any formative or final decisions that they made. I wrote down what they said, when, and if they offered any justification, I recorded that as well. Here's a sample of the data set that I gave them. It's a Faces in the Wild data set. There are 171 images, and they were 71% people who appeared to be male and 89% people who appeared to be white. So to give you a sense of what recognition looked like in this data set, I'll read you one from participant 1. So random selection of these, good. I wonder what the variety or span of that was. Okay, so it came from, where's it from? PhotoBucket. Okay, so whatever the demographics are for PhotoBucket, that's what I can expect here. It'll be interesting to know how they decided whether it was a face or not in order to create the labels that they had. Perhaps they did with humans, perhaps, or used a pre-trained model, and that could introduce errors in the data set, biases. I knew what they were looking at, by the way, in this case, because the user was tracking mouse over the text as they read, and this was in the datasheet. So participants in both groups recognized and mentioned about the same number of issues, but people with data sheets were much more likely to mention it while they were working, instead of, for example, after I asked them in the interview. This may signal that data sheets are causing people during particularization to say, yes, this is part of my task. And if that's the case, I think data sheets are doing their job. So for particularization, people particularized from around 30 seconds to around 9 minutes, on average about 3 minutes. There was one participant who didn't notice any ethical issue and also therefore did not particularize. Among people with data sheets, most particularization was done with data sheets on the screen. They reflected on existing knowledge and beliefs, sought or indicated that they planned to seek information, and relied on study materials. They mentioned examples of past engineering and failures and successes, trade-offs, and discussed options with resources and risk. They also built and relied on their own understanding that they developed during this phase, and I will give you an example of what that looks like. So these are two participants who both were relying on their understanding, their existing understanding of false positives, the consequences of false positives and how they relate to this situation in particular. So what happens if your model says something and it's wrong? That's the main thing I want to know. How bad can that be for a person? And if it's really bad, then you have to seriously consider, like, is using a model here going to provide a benefit or not? And how can we make sure there's sufficient human in the loop involvement? The main goal will be true positives. And at least in these types of situations, I guess the goal is to catch as much as possible. So not a problem if it's false. We will tilt a bit more to okay if we have more false positives than if we have false negatives. In this case, some thief appearing and not being identified will be more costly. So a few takeaways. Data sheets helped, I think. Participants read data sheets. I was a little worried that they wouldn't. They noticed ethical issues while they were working and when asked. And people with data sheets mentioned issues more while they were working, and they relied on them while they were particularizing. We can also take some things away about the study of ethical sensitivity in social computing. First, ethical sensitivity can be used to test interventions in this way. I also believe that a similar method could be used to develop, evaluate, and improve ethics training. think-aloud is useful for studying ethical sensitivity, especially particularization, which is a part of ethical sensitivity that traditional methods have struggled with in the past.